Example 2. If the rate of smoking in the country is really 20%, find and interpret the mean and standard deviation of the sample proportion for a sample size 400. So let's look at the mean first. The mean is the easier one, right? So we would expect the sample proportion, p hat, we'd expect p hat to be very close to 0.2. The standard deviation, again, is the square root of p q over n. So p is 0.2 times q, which is 1 minus p, at 0.8, all divided by a sample size of 400, and I'm taking the square root of all that. And when I put all that in the calculator, I'm going to get 0.02. So that is my sigma of p hat. If I were to draw this out, and we can get a sense for this, right? So one standard deviation above this would be 0.22. Two standard deviations would be 0.24. And then I go one standard deviation below, it would be 0.18. And then one more would be 0.16. So we would expect 95% of these samples to be between 0.16 and 0.24 if the true population proportion were 0.2. Okay, so find the probability that less than 15% of the sample of 400 people will be smokers if the true proportion is 20%. So again, let's draw this out. And on the calculator, okay, if we have the new model of calculator, I'm going to go ahead and press second distribution. Number 2, normal CDF. -1 E99. Upper would be 0.15. The mean is 0.2. Standard deviation was 0.02. And we'll press enter. And we get 0.0062. And that is the area of that region there. And that's the probability that less than 15% of the sample of 400 people will be smokers if the true proportion really is 20%. Example 4, the probability 0.0062 is the same probability we calculated when we found the probability of getting 60 or fewer smokers out of 400 in an earlier lesson. Why is this? So let's consider this. Let's go ahead and draw this out. So in an earlier lesson, we looked at, we didn't have proportions on here, we actually had numbers that were nice integer values. And the mean here, if it is 20% of 400, would be 80. And if we do the norm CDF on this, my sigma, this is a binomial, would be the square root of 400 times 0.2 times 0.8, which ends up being 8. So distribution number 2, that's going to be the same. My upper here is 60. My mean was 80. Again, that was 20% of 400. That's the mean. That would be the expected number of the 400 that would be smokers, if 20% are smokers. And sigma here is 8. And look what we get. We get exactly the same value. Again, should be no surprise. If I convert all these to proportions, I'm basically just dividing each of these by my n. We could also look at computing this as an actual binomial. And you'll see that it's going to be very, very close to this. CDF, number of trials, 400. P is 20%, 0.2. And we're going all the way up to 60. The exact proportion would have been 0.0061 if I'm rounding, or off by about 1/10,000th of a place. But we use the normal distribution to approximate binomials.